Hello, young math Padawans. It's Mrs. Angel with your final lesson number 3, solving quadratics with the actual complete the square method. So we're going to take everything that we learned in the other 2 lessons and apply it to now solving using this method. And this method isn't just used for solving quadratics. It can also be used to convert a quadratic from standard into vertex form. And later on down the road in calculus and beyond, you use complete the square method a lot. So it's a good thing that we're learning it this early on. Grab some notes and let's get started. So the first thing we have to do using complete the square method is we have to take a trinomial that's not a perfect square and change it into one. So b squared minus 16b plus 60 is not a perfect square. And the reason why is because you can't take the square root of 60. So let's go through our series of steps. Step 1, we're going to make space for a new third term, meaning we're going to put something new in place of 60. But mathematically, you can't just wave a magic wand and make something disappear. We're going to make space by using a property of equality and creating 0 out of that 60. To do that here, we would subtract 60, and because of that property of equality, we'd have to do it to both sides. What does that leave us with? That leaves us with b squared minus 16b plus essentially nothing equals negative 60. So we've kept the equation equivalent. We haven't changed its value, but now we have space for a new third term. But what is that third term going to be? That brings us to step 2. To find what that third term is, we know it has to be a perfect square. And we know that the square root of that term and the first term have to double to make the second term. So we're going to undo that math. We're going to do the opposite of doubling, which is taking the half, and the opposite of square rooting, which is squaring. Let me show you what we mean. You're going to grab the coefficient of the second term, negative 16. You're going to divide it by 2, and then square it. So negative 16 divided by 2 is negative 8, and negative 8 squared is 64. So 64 is the magic number that will help us complete this square. That brings us to step 3. We're going to add that number to both sides of the equation and simplify. So bringing down the first 2 terms, b squared minus 16b, now we're going to add 64 as that term and bring down the rest of the equation. However, addition property of equality states if you add to one side, you better add to the other. So we also need to add 64 to the other side. Our equations are equivalent. The only difference is we've now filled in a different third term. Let's simplify. Well, the left side can't be simplified anymore, so I'm just going to leave that as b squared minus 16b plus 64. But the right side, negative 60 plus 64, is positive 4. So what have we just done? We've created a perfect square trinomial. If we look in here now, we can take the square roots of the first and the last term. That would be b and negative 8. And when you multiply b and negative 8, they make negative 8b, which guess what? That adds up to the middle term of 16b. So now we can factor this perfect square. So to factor it, we're going to set up our binomial square equal to 4. The square root of b squared is b. Square root of 64 is 8. And because we have subtraction in our trinomial, we know that we're dealing with a negative 8 or subtraction in our binomial. So what have we actually done? Well, with one more step here, if I were to subtract 4 from both sides, I could say that this quadratic is now officially in vertex form. So I've actually gone through the process of converting. We wouldn't do this if we were trying to complete the square, but I just wanted to show you that quick trick. By converting it into something like vertex form, we can now solve this quadratic using the square root property of equality, which we should already feel pretty familiar with. Just in case you need a little refresher, let's go ahead and solve this to completion. So step 1 is to identify the power. In that case, that would be our b minus 8 squared. Step 2 is to isolate the power, and actually this is already isolated, so we don't have to do any type of isolating. So step 3, we're going to take our quadratic b minus 8 squared equals 4 and take the square root of both sides, aka the square root property of equality. Now, since there are 2 square roots of 4, we're going to set up 2 equations, one equal to positive 2, the other to negative 2. So b minus 8 equals 2, and b minus 8 equals negative 2. Let's solve. And b equals 10, and b equals 6. Now, there's only one way to be sure, and that's with a full check. Now, when we do check, notice how it says that we need to check in the original function. If you recall, we weren't given this function to solve. We were given this function to solve. So that's the function where we need to plug in and check the standard form function. So let's go ahead and check both of our solutions. All right, looks like 10 was a solution. Let's try 6. And voila, they were both solutions. So that means that this quadratic has 2 zeros, and they are 10, 0, and 6, 0. But remember, it's not just this quadratic, but actually this one. So if we were to solve this one, we would again say that the 2 zeros here are 10, 0, and 6, 0. Here we have v squared minus 18v plus 80. I can already tell that it's not already a perfect square trinomial because we can't take the square root of 80. So we need to make space for a new third term, one that is a perfect square. So let's get rid of that 80 by subtracting it from both sides. That brings us to a new quadratic, v squared minus 18v, space for a new term, equals negative 80. Now we need to figure out what new term we are going to put in there. So take half of that coefficient of the middle term and square it. Half of 18 is negative 9, and negative 9 squared is positive 81. That's going to be our new third term. So here's our new function. V squared minus 18v plus 81 equals negative 80 plus 81. Because if we're going to add a term on the left, we'd better add a term on the right. After simplifying, we have v squared minus 18v plus 81 equals 1. So did we make that a perfect square trinomial? Well, let's see. The square root of v squared is v, square root of 81 is 9, or negative 9, and negative 9b plus negative 9b is negative 18b. So since this is now a perfect square trinomial, we can factor it as a perfect square. Set up my binomial square and finish off the rest of my equation. Square root of v squared is v. The square root of 81, that will also make this subtraction, is negative 9. So now that this quadratic is essentially in vertex form, we can finish solving it using the square root property of equality. Step 1, identify the power. In this case, that's our v minus 9 quantity squared. Step 2 is to isolate it, which we don't have to do because that's already been done. So we're going to move on to step 3. Take your power, v minus 9 quantity squared, and take the square root of both sides, applying the square root property of equality. Because there are 2 square roots of 1, we're going to set up 2 equations. V minus 9 equals positive 1, and v minus 9 equals negative 1. Now we can solve. And we end up with v equals 10 and v equals 8. Of course, we're never really sure until we check. Since the directions here are to check in the original function, I already went ahead and wrote that out. So let's check 10. All right, it seems that 10 is a solution. Let's go ahead and check 8. And 8 is also a solution. So that means that this quadratic has 2 zeros, and they are 10, 0, and 8, 0. But since the quadratic we started with was on the previous screen, I'm going to put those here. 10, 0, and 8, 0. Final example of complete the square. So we can tell this isn't a perfect square trinomial because 3 is not a perfect square. We also notice that it's not set equal to 0, but that's okay in this case. Don't worry about that. Step 1 is to make space for a new third term, which means get that 3 out of there and subtract it from both sides. So our new function here is going to be x squared plus 14x, leave space for a brand new term, equals negative 11. What is that term going to be? Well, to find that, we're going to take half of the middle term, 14 divided by 2, and square it. Half of 14 is 7, and 7 squared is 49. That will be the term that we put in that space. So our new quadratic is x squared plus 14x plus 49 equals negative 11 plus 49, because whatever you add to one side, you must also add to the other. After we simplify, we get x squared plus 14x plus 49 equals 38. Okay, let's see if we can now take the square root of that perfect square trinomial. I can tell this is a perfect square trinomial because the square root of x squared is x, square root of 49 is 7, and 7x plus 7x do add up to 14x. So we can factor. So we set up our binomial square, finish the rest of the equation, and here we go. Square root of x squared is x, square root of 49 is 7, and this equation has addition, so we can leave this as x plus 7 squared equals 38. So now it's in vertex form. Let's apply the square root property of equality. I've already gone ahead and identified the power and confirmed that it's already isolated. So we're ready for step 3. Apply the square root property of equality and take the square root of both sides. But hold on, is 38 a perfect square? It's not, which means our solutions here are going to be irrational. So that's going to change when we do our check, but it's not going to change how we continue solving. There are 2 square roots of 38. They are the square root of 38 and the negative square root of 38. So we're going to still set up some equations here. Equation number 1, x plus 7 is equal to the square root of 38. And equation number 2, x plus 7 is equal to the negative square root of 38. Both are numbers that if you square them, they'll give you 38. So let's solve. So one of our solutions is x equals negative 7 plus the square root of 38, because that's the positive square root, and x equals negative 7 minus the square root of 38. These are actual values and these are actual zeros. They're just irrational, which is actually why complete the square exists, so that we can find these irrational zeros when given a quadratic in standard form. Let's check them. Now, because we're in an Algebra 1 class, I'm not going to have you check these zeros in the original function. I'm actually going to have you check them in the vertex form function, because I don't know that we're at the level yet to fully check these types in a standard form function. I'm pretty sure that if you asked your teacher, they would be happy to do that for you. For the sake of this video and this teacher, we're just going to check any irrational zeros using the vertex form. So let's start with our negative 7 plus the square root of 38. Okay, well, as we can see here, we have a negative 7 and a positive 7, which equals 0, leaving us just with the square root of 38 squared equaling 38. And to undo a square root, you're going to square. So that leaves us with 38 equals 38, and we know that this is indeed one of our solutions. Let's check the other one. Again, we're going to have negative 7 and positive 7 make a 0 term. So that leaves us with the negative square root of 38 squared equals 38. And a negative times a negative is always positive. This also equals 38, meaning that this is the other zero of this function. So what are the zeros here? Believe it or not, this quadratic has 2 zeros. They are negative 7 plus the square root of 38, comma 0, and negative 7 minus the square root of 38, comma 0. Because we checked them, and like I said, if you ask your teacher nicely, maybe they'll show you the check in standard form. For now, that's it for today's lesson on Complete the Square, and I will see you next time.